Hello everyone. In this video, I am going to take up MCQs on topic normal distribution. So before starting the MCQs, I would like to have a one glance for the important formulas and properties. Normal distribution is a continuous probability distribution and it is also known as Gaussian distribution in honor of the Carl Friedrich Gauss, right? And its PDF is written in this formula and it is very important. Why? Because many questions will be based on it. The range of x and mu is given for all real number. Now one important result is that standard normal variable, because when we know that it is a non-standard which is denoted by capital X, it has a two parameter mu and variance, or sometimes we can write a standard deviation also. And the standard normal variable is written with this formula. It is an important one because whenever we want to switch from x to z, we will use this formula. What is important to remember, because it is a standard, it means any non-standard with whatever mean and variance, if we want to switch to the standard one, it will always have a mean 0 and variance 1, or standard deviation also 1. Now let's look up at some features which is saying that it is a bell-shaped curve. We can see it from this diagram. The shape is bell and it is symmetric about the vertical axis through mean, and we know that the location of mean is here at the center and it is what symmetric on both sides. That means both sides we are having a same picture. Now the total area under the curve is 1. We know that PDF, the full area is 1, or a total probability is 1. So when we say the continuous probability distribution, PDF means area under the curve. So it is 1, that we already know. But here, due to symmetric nature, we can get one more clarity, that area to the left and right are same, because if this side is a 50%, or you can say 0.5, the right side will also be 0.5, right? And the mean, median, mode are equal for that. This is a distribution where all mean value is also the same, median is same, and mode is also same. And if we want to see that what is the maximum value of the PDF, we know that here when we look into the graph, we can see that this is the maximum height. That means it is a value where we get a maximum PDF, and it is at a location of mu. And when we plug in mu over here in place of x, we can get this value become 0, and when we simplify it, we'll only left with this expression of 1 upon, you can see from this fx, sigma upon root 2 pi. So if we want to find out what is its value, maximum value, so we can see this value as a maximum. And since we have already covered this z value and fx, if we want to rewrite it into the z, so we can replace the expression in the PDF of x minus mu by sigma as a z, so we can rewrite it into the probability density function of z. One of the important result we can observe here is an empirical rule, and this rule says that we want to get an idea that whenever we want to see the area between two standard deviation, one standard deviation, three standard deviation, so this says that within the one standard deviation the area covered will be 68.26. It means if your mean is located at the center, and if you take the value on the left hand side and the value on the right hand side, which is at an equidistance of a one deviation, the area cover will be 68.26, or in terms of probability it will be 0.6826. And same is for the two deviation, it is 95.44, 0.9544 in terms of the PDF. And by the time it took the three deviation steps on the left and right, we get almost total area covered within it except little part. So it means 0.9973 of the area can be covered within the three deviations. So sometimes in MCQs where the table value is not given, but we are clear that the location of the points are at the one deviation, two deviation, so we can make use of these results for the problem solving. So when problems will come, we will look into that. And some more point is there about the z value. Sometimes a question can be included in this topic, which is that what is the interval that covers, means what are the z value within which the 90% of the data is covered, 95 and 99 is covered. So we can remember that within the 99%, I means within minus 2.58 to plus 2.58, the 99% of the area is covered. and for the two values of z, which is minus 1.96 to plus 1.96, 95% of the area is covered, and between minus 1.645 to 1.645 it is 90%. And you must be observing, if you have done the testing of hypothesis topic, there also we use a z test, and you must have observed that whenever we are setting a level of significance of 5%, 10% or 1%, we use these values. It means they are the critical values within which the areas lies for the acceptance. So sometimes in this topic of the normal distribution also somebody can ask these problems, so we should remember these points. Now we will see the moment generating function formula, that it is e to the power mu t plus t square sigma square upon 2, or even sometimes it can be written in the simplified form like that. So whatever way it is written, we have to remember what is the correct power, right? And the same formula, if I want to reduce into the standard normal variable by putting mu is equals to 0 and sigma square is equals to 1, it will turn up to be e to the power t square by 2. Now MCQs I have framed in such a manner that starting 5 to 6 MCQs are totally a property based. So I will suggest that when we are discussing these 6 questions, you just pause the video, keep your answer with you, so that when I will share you can tell me whether you remember or not. So let's see the first question. It is talking about the standard normal distribution, which is the which of the following property. Obviously we know that the mean and variance are the fixed value of it, and they are 0 and 1, so only C option seems to be the correct one apart from the others, so this becomes the right option. And when we see the question 2, the normal distribution is symmetric about what? Obviously it's a mean. We have just seen from the diagram that mean is the central value which divides the area into two equal parts, so it is symmetric about mean. And the shape is bell shaped because they are asking us the normal distribution curve shape is bell. So these are the few questions based on the direct property. 4, 5 question we have just discussed the empirical rule because they are asking us area between the one standard deviation. So between the one standard deviation we know 68.26, but the question is talking about not in the percentage, so in terms of the PDF, so it is 0.6826. And for the 3 deviation we know that it is 9.9973. so we do not have to make mistake of 0.9 and that it is similar, but it is more accurate to the 3 deviation, which is 99.73 percentage. The sixth one is a direct formula based question, a memory based question, which is talking about the moment generating function of the standard normal variate. It is asking the standard, so we have to be very careful while reading the question, because sometimes what happen, we casually look into the question and take the wrong option, because both the non-standard as well as the standard answers are available. So standard one is this one, C1, so it is a formula. Now let's see the next one. Here x is given with the mean 5 and I'm going to take it a variance is 1, and they are looking for the PDF. We know that, let us recall the formula for the PDF. It is 2 pi e to the power minus half x minus mu whole square divided by sigma square. So this is in the power of e, right? E to the power. And when we observe out of the 4 option, sigma is 1, so we have to be very careful there. Sigma is not 5, so 1 A and C option is wrong. Next, when I see the power, here x minus mu, that means x minus 5, and I am observing there is no x minus 5, so only x minus 5 is here, so we got the last option is the correct one when we want to find out. So not a big deal for this question, only we need to remember the formula for the PDF to get the right answer. I have also taken up some questions from the previous GATE examination because the questions are of the good category, so I have included in this file. They are based on logic and fundamental. Even some questions don't need a lot of calculation work. Just with the logic you can get an answer. So this is 8th question is one of them. The question says that the random variable x has the following PDF. then integration from 1 to infinity fx dx. So point is no other data is available, so we have to first identify that what we can gather from this PDF, because we know that PDF contains the what we say parameter of the distribution, so mean. So let us first identify that when I will compare it with sigma root 2 pi e to the power minus half x minus mu whole square to divided by sigma square. So from here, if I start from this, I need 2 here, so if I take 4 out, it become 2, so I got this value as a 2. So we got a standard deviation is turning up to be the 2. And when I simplify the power part, I can see that x minus 1 means x minus mu. So we got a mu value is equals to 1 and sigma value is equals to 2. So when I want to see how to or what to calculate in this question 1 to infinity, remember that in the continuous distribution, when somebody is looking for the integration, it means it is talking about the probability from the point to another point, or we can say area under the curve. Since we have retrieved the mean location as a 1, it means this is a 1 value and it is at the center position. We are looking for integration from 1 to infinity, that means it is same as probability of x greater than 1 till obviously infinity. And we know that this part is 50% of the area, and 50% of the area, when I see here they are asking us 1/2, so B option is turning out to be the right, because this much area is a half, or you can say 0.5. So we observe that just by uh, getting the value of mean, we got the answer. In this ninth question, they gave us a thickness of a polyester film base has a mean 140, standard deviation 2. Now they want the probability tested between 138 to 143 written in the standard normal variate. So what are important point to remember here, that we want to find that what is the conversion of this normal variable to the z. So what is first point, that formula for z is x minus mean. So mean is 140 in the question, divided by standard deviation, which is 2 in the question. So when I will apply, what we can do, subtract the value of the given x from the mean, which is 140 divided by 2. X, when I do the same thing, because it is a variable, so it will switch to the variable of the standard, and the point will be switch over to the point. So 148 minus 140 upon 2. So we observe that here we have a minus 2 value. So P from minus 2 by 2, which is equals to minus 1, and 148 means it is, I'm sorry, it is 43. I made a mistake here, 43. So when I say 43, it will be 3 by 2. So 3 by 2 is 1.5, so minus 1. So from minus 1 to 1.5 seems to be the option B. And it is just in this question, they are not asking us to evaluate the value, they are asking to switch from a non-standard to the standard one. In the 10th question, it is also taken up from some previous examination, competitive examination booklet, which is saying the mean is 100. So first, because graphically is the best way to deal with the question of the normal distribution, you can easily identify a whole structure. The mean is 100, and they gave us the probability from 100 to 120 is B. So 120 is on the right hand side, and from 100 to 120 the information is given in terms of this unknown B value. And what it is looking for, what is the probability of x less than 80. So 80 is on the left hand side. What we are observing, that 100 to 120 this much, and 80 to 100 both are at the same distance, right? So it means the curve is symmetric, so obviously the area on the right hand side till 120 is same as area till 80 from 100. So it is also B. We do not have, there's no other question. So what we are observing, that my required PDF can be evaluated since I have identified the area of 80 to 100 is B, and since this area is half, and I can calculate half. When I delete B, I'll get my answer. So 1 by 2 minus B is the required value for this. And in this question they have simplified it, so C, it seems to be the right option, this one. Okay, this is also of the same nature, but let's see what this question is about. Mean is 0 and variance is 9. It means mean is 0, so mu is equals to 0 and variance is 9. Probability of x greater than or equals to 3. In continuous data, whether it is strictly given or with equal to sign, one and the same thing, we do not have so much difference in the calculation work. So here more than 3, so obviously 3 is on the right hand side of the 0, which is first of all we have to get out of this model, and we know that when we want to write down it in terms of an interval, it can be whatever is written inside the mod, you write in the center, and this number with the negative value on the left hand side and with this positive value on the right hand side. So we can observe that they are asking me from -3 to 3, and already 3 is located in the diagram. I can write down the -3, and this is the required one. We are looking for this much probability. Since due to the symmetric nature, we are observing 0 to 3 and -3 to 0, they are same distance. It means if right side of the 3 is A, then left hand side of the -3 is also A. Now our question is almost done, that if you are looking for the area between -3 to 3, what you can do is from 1 you can delete the double A value, so it is 1 minus 2A, and the option D becomes the right answer. This is something seems to be similar like a previous, but here they have given us a value. So first of all, I want you have to get out of this mod sign. Mean is 30 and standard deviation is 5. So when I want to rewrite this expression, so first is I'll write down x minus 30 in the center, and this 5 with the -5 on the left hand side and +5 on the right hand side. And now since I don't want the 30 because I have to convert it into the standard form, so before that I need a x value in the middle. So first, if I want to get rid of this -30, I should add 30 everywhere so that we can compensate it. And this -5 and 30 will turn up with the 25 value of x, and the central become x and the right side become 35. Now in this question, because if I want to write down because data is given in terms of z, so first let us switch from x to the z with the mean value is 30 given in the question, standard deviation is 5 in there. So what we will do, we are going to work on the same thing. In place of x, write down 25. 25 minus 30 is -5, so -5 by -5. X minus 30 by 5 will turn up into the z value. 35 minus 30 will give us a 5 upon 5, and we are observing that the value is actually between -1 to 1 for the z. And when we see in the diagram, the z value is 0 at the center, and the value of -1 to 1, they gave us a value between this part, so they are asking us this answer. So yes, so they give us a 0 to 1. So if 0 to 1 value is given to us as 0.341613, due to symmetric, this is also 0.3413. It means we can add them, or you can say the answer is 0.6826, which is option A is the right answer. The question number 12 is the annual precipitation data is normally distributed with mean and standard deviation 1000 and 200 respectively. The probability that the annual precipitation will be more than 1200 millimeter is what? So they gave us in terms of the percentage. First, let's look into the situation. that the central middle mean value is 1000 millimeter. uh, the value required is more than 1200, and it means this value is required. I don't think we have to work on anything more, because what we are observing, they are asking is the percentage of more than 1200. So it is very clear that the area on the right hand side of the 1000 is 50%, and we are far ahead with the 1000, which is 1200, and the value cannot be more than 50. So less than 50 is the only appropriate solution for the question 12. What I did, I extended this question with some calculation work so that we will try to figure out how we can solve when some values is required. So we are observing that in the previous few question I gave you the z value or sometimes the x value, but in this question no data is given, no table is given. How we can handle such kind of situation? So first of all, let us plot the same thing which we discussed in the previous question. The central value is 1000, this is 1200, and we are looking for the area in terms of now accurate answer. So let's try to identify the availability. They gave us a sigma value as a 200. This is mu. Now here the empirical rule can be used. What I am observing that 1200 is at a distance of what? If mu is we have discussed the empirical rule. I'll show you the slide so that you get an idea from here. You can see from here that if you are looking for the probability between one standard deviation, means one deviation from the left and right, you will get an area which is 0.6826. Percentage wise it is 68.26. So I'll use the point form because in my question it is given in terms of the PDF. So I'll use 0.6826. That means this much area is given, right? And we only need from 0 onward. So what we can do, not 0 onward, mean onward. So mean onward I need a half of it, so I can take a half of 68.26 to get my required answer. So using empirical formula we can handle this question, and we can do it like that from 1000 to 1200. This is a half of the 0.6826 value, so it is equals to 0.3413. So it means this area I got, or this PDF I got 0.3413, right? And if this is 0.3413, am I able to now retrieve my answer? So obviously yes, because this much area is, or this much PDF is 0.5, and I just have to do what? I'm looking for probability of x more than 1200, and this can be evaluated by just subtracting the value between 0 100 sorry not 100 1000 to 1200. That means 0.3413, because in MCQ we do not have to write all the things in a very detailed manner. We have to play with the numbers, and we should see that what to do, what to add when we simplify it. So answer is coming out to be 0.1587. You can verify it, right? Now let's move ahead with the more questions. In this 13th question, I am taking up 22 questions, so some few question I would like that is to be done by you only. So let's see the 13th one. It is saying x is the normal variate with mean 30, standard deviation 5. What is the probability between 26 to 34 if we give you area of z greater than 0.8 to be 0.2118? So sometimes in the normal distribution the information is given in terms of area, sometimes in terms of PDF, sometimes in terms of integration. So to give a variety in the problem, but the information will be taken in any way. So the point is the mean location is 30, so I'm going to plug in over here 30, 26 is here, and 34 is here. Now in this question we have to switch the question to the z because data is available in the z form. So point number 1 is z is equals to x minus mean, which is 30, divided by sigma, which is 5, So when we switch from 26x to 34, what we need to do is from 26 minus 30, I'm directly subtracting. 26 minus 30 is minus 4 divided by 5 less than equals to x minus 30 divided by 5 will convert it into z. 34 minus 30 will give me 4 by 5. So we can see that this is minus of 0.8 and this is plus of 0.8, and we can see that when we convert it into z, this becomes 0 for the z, and this become minus 0.8, and this become 0.8 value. And as per the given information, 0.8 more than value, this value is given to us as a 0.2118, and the question is demanding the value between 26 to 34. So the thing is, what we can do, either we can convert it into 0 to probability from 0 to zero point 0.8, then double the answer, or other option is that if this side is 0.2118, this side is also 0.2118, right, because it is a symmetric. Right of the 0.8 and left of the minus 0.8 is almost same, so we can do what is there. So I know the full answer is 1, so instead of doing it I can say let us delete the double value of 0.2118 to get the answer. So when we simplify, the option D will be the right answer. So you can simplify it and tally your answer. So that becomes the answer point. I want you to verify, right, because 2 2s are 4, and when we simplify it will be 5 7 6 4. So that is the 13th question. Question number 14 is the mean of the normal distribution is average of first 10 natural numbers. That means mean is given to be 1 plus 2 plus till 10 divided by 10, and we know that the sum of natural number, 10 natural number here is 55 upon 10, so it is 5.5. So it means mean is 5.5. So they are asking us the probability between 4 to 7. So first of all, let us see that from 5.5 mean value, the location of 4 and 7, is it at equidistance? So yes, when you subtract the difference between them is 1.5, 1.5. So it means they are same. So it is same. And they said from mean, I mean, so they said that probability of x less than or equals to 4 is 1 by 5. So it means this is 1 by 5, since due to the symmetric, if left side of the 4 is 1 by 5, because it is also at the equidistance and this is symmetric, so this is also 1 by 5. So when both side is 1 by 5, can I calculate my this value? Yes, I can calculate my required answer, which is probability of x between 4 to 7 is equals to, from 1 we can delete the double value of 1 5, and it is 1 minus 2 by 5, which is equals to 3 by 5. So option D becomes the right answer for that. Now the 15th question is of the MGF, and this is given in the X form. We want to first rewrite it into the standard form, which is e to the power mu t plus t square sigma square upon 2. So first we are observing that t power should not have anything in the denominator. So when I simplify it, it will be 24 by 2 is 12t, and this side I need a 2, so I'm not going to cancel with the 16, so I'll keep it as it is, so that to get our variance. So variance is 16 and mean is 12. That is option number 3 C, sorry. I want the 16th question to try yourself, because it is again a direct one. They are looking for the standard value, which is z corresponding to 35 with the mean 65 and variance to be 25. So you can calculate and share your answer in chat box. I'll see whether you have given the correct answer or not. In the 17th also, I want you to do it yourself. Here the mean is 32, variance is 9 because variance is given. It is always be careful in these topics. They always mention whether the variance is given or standard deviation. So accordingly you have to pick the values. So they are looking for 27 to 37 and some value is given. So obviously it must be coming up into the 1.6667 something. So you use it in the same manner. We have already taken up the question of the same type in a previous two sets. So I want you to do the 17th one on your own. 18th I will share with you because it is different. They gave us a PDF and they are asking the mean and variance of the normal variate. So the step number one is we need to write down into the standard. So first of all, let us recall the formula. E to the power minus half, then we have a x minus mu, that is whole square, sigma square. Okay, when we, let's win by one, let's first entertain this one. Here 32, I want 2 pi, so 16 can be taken out. So when 16 will be out, it will be 4. So I got a sigma value as a 4. Now we are going to simplify the e to the power portion, which is written in terms of exp or e1, and the same thing. First point is I want no coefficient of x. So when I take up 2 common, what will happen? 2, when it will be get out of the bracket, it will be squared. So 2 square become 4 here, right? And this become 1. And when you are taking 2 common, obviously this 5 become 10. So what we are getting in the e to the power, this is minus 1 by 32, x minus 1 by 10 to the power square. So from here we get this 32 is nothing but it is 2 times sigma square, which is 16. So we got sigma 1 by 10 is 0.1 and variance is 16. In this 19th question, they gave us if x is a normal random variable with mean, mu and variance 9, z is a standardized normal random variable such that probability of x less than or equals to 15 is probability of z less than. Now what you are observing in this question, something is unknown, mean is not known, but they gave us a relation of two different PDF and they are giving us it is same. But before comparing anything, the model should be of the same type. One side they gave us in standard value and another side they are giving us a non-standard. So the step number one is when you have a question like that, for convert it into the same model. So I'm going to convert this left hand side into the standard, and we know that z is equals to x minus mu upon sigma, which is 3. Variance is given to us. So when we convert x, so x becomes z because variable will become into the variable. 15 I am going to write down mu, which is unknown still now, is equals to this thing. So right side is already in the standard form. So how we can compare it? Both are exactly same, so it means this value must be matching with the one. So when we simplify it, we get 15 minus mu must be equals to 3. That means mu is equal. This is also something similar, because here we are looking for not mean, we're looking for the x value. They are saying it is given that x is a normal random variable with mean 40, standard deviation 6. Z is a variate such that probability of z is less than or equals to minus 0.13 is 0.45. Then the value of x that has a 45% of the area to the left. So first of all, let us see how it is available. We know that this location is 40 for the mean, and we don't know the left hand side. This must be a 40%. 0.45 is a 45% is a 0.45, and this value is x, which I don't know. The value of x they are asking, so we don't know what is this value and we want to find out. Now what is available? They gave us information in terms of z, and we know that z and x have the normal formula. So the step is how we are going to convert. So for z is equals to 0, we have a 40. This is matching at the location, and since they have also given us a 0.45 area as this one, that means this value x is matching with the minus 0.13 value, and this is same. So how we are going to turn up with the question? The step is, this is given in x, this is given in z. So step is to convert value into z. So what I can do, this value when converted into x, this is x minus mean, which is 40, divided by standard deviation, which is 6, must be matching with minus 0.13. Cross multiplying 6 with 1.6, and when we will see this is x minus 40 is equals to minus 0.78, and when you simplify it, x is coming out to be plus 40 minus 0.78, which is turning out to be the 39.22, which is option number A. 21 is a mark scored by 1000 students in one subject that are normally distributed with mean 40. If 400 students have got a marks between 40 to 60, what is the percentage of the students scored marks below 20? Since they gave us a data is a normally distribution, it means the curve of the marks must be like this, bell shape. And they said that the mean is 40. So marks 40 is a mean marks, central value. Next, they gave us that 400 student got marks between 40 to 60. So 400 student out of 1000 means what is a PDF? So we can say 400 by 1000 is 0.4. Next, they are asking that what is the percentage of student who scored marks below 20? So we can say below 20 must be here, and they are asking us this value. So what we can do, due to the symmetric nature, I am observing 40 to 60 distance and 20 to 40, they are same. It means from mean these two area must be same, so PDF must be same. So this will also be 0.4, and since we know that the area on the left hand side of the mean is 0.5, and when we subtract 0.4, this area is turning out to be 0.1. So 0.1 is a PDF, means 10% is the number of the student who scored less than 20. 22nd question I want you to do yourself, because this is something we have seen in the beginning of this discussion regarding a confidence interval or the interval of Z, which is giving us an area of 99, 95 and 90%. So they are looking for the 99%. You can follow that step and tell me what answer you can give for this 22nd question. So I hope you have gotten some information for the how to deal with the questions on normal distribution. Thank you for watching.